This video will give examples with binomial experiments. You have a coin. What is the probability you get heads 2 or fewer times if you flip 5 times? So let's write down our formula for a binomial experiment. The probability of getting n heads is equal to combination, we're doing this 5 total trials, n successes, times probability of success to the power of number of successes times the probability of failure to the power of the number of failures. So this means that the probability that I get 2 heads is equal to combination 5 choose 2 times 1/2 to the power of 2 times 1/2 to the power of 3. Probability of 1 head, combination 5 choose 1 times 1/2 to the first times 1/2 to the fourth. And lastly, probability of 0 head is equal to combination 5 choose 0 times 1/2 to the 0th times 1/2 to the 5th. Doing the math, I find that this is equal to 10 over 32, 5 over 32, and 1 over 32. So now the probability that I get heads 2 or fewer times is equal to the sum of all of these individual probabilities. So if I add these 3 probabilities together, I end up with 16 over 32, or 1/2. I guess randomly on every question on a 5-question test, where each question has 4 multiple choice answers. What is the chance that I pass, which means that I get 60% or higher? 60% corresponds to getting 3 of the questions right. So this means I'm going to have to add up the probability that I get 3 questions right, probability that I get 4 questions right, and the probability that I get all 5 questions right. So for 3 questions, this is equal to combination, there are 5 questions total, 3 successes, times the probability of success is 1/4, because I'm guessing randomly out of 4 answer choices. Number of successes is 3, and then the probability of failure is 3/4, and I'm going to raise that to the power of 2, because that's my number of failures. I'm going to do the same thing with 4 questions and 5 questions, so combination 5 choose 4, 1/4 to the power of 4 times 3/4 to the power of 1, and this one is combination 5 choose 5, 1/4 to the 5th times 3/4 to the 0th. And so doing the math, that comes out to 90 over 1024, 15 over 1024, and 1 over 1024. So if I know the probability that I get at least one of these, then I can just add up the probabilities. So 90 plus 15 plus 1 over 1024, which is about a 10% chance that I pass. So this is a pretty low percentage. In other words, if you want to pass your test, you should study and not guess randomly on every question. Here I have a few experiments, and I want to classify them as either binomial or not binomial. The first one, I draw 7 marbles out of a bag of blue and yellow marbles, replacing them, and I record the number of yellow. This is a binomial experiment because I have a fixed number of trials, 7. I'm replacing them, so my trials are independent, and there are only 2 choices, blue and yellow, so I have success and failure, and the probability of getting a success or failure each time is the same. The Johnsons record the number of children they have before they get a girl. This is not binomial because the number of trials is not fixed. So I'm going to move this under not binomial. And then I flip a dice 8 times and count the number of 5s. This one's a bit tricky. So I know that n, the number of trials, is fixed. The probability of success each time is the same, and flipping dice is independent. But I have 6 possible outcomes when I flip a dice. So does this count as binomial? In fact, it does, because the probability of success is 1/6, and the probability of a failure is 5/6. So it doesn't matter about the other outcomes, as long as you're only looking at the two, success and failure.